Welcome to qnawire.
In this problem, we're asked to find the gravitational force that the moon exerts on a person when the moon's directly overhead. So we're told that the moon is 378,000 kilometers away from the person. So we have our moon, we have our person happily hanging out on Earth, and I've gone ahead and converted that distance into meters since that'll be more convenient for working in our equations. So to find the gravitational force, as we've been doing, the force that the moon exerts on the person is just going to be equal to the gravitational constant g times the mass of the moon times the mass of the person, and then divided by the distance between the two squared, so r mp squared. So we know all these values, so we can evaluate this right away. So gravitational constant, 6.67 times 10 to the minus 11th. I'll leave off the units on that for now. The mass of the moon, so we aren't given this, so we have to look it up in the appendix, and that will be 7.35 times 10 to the 22nd kilograms. And then the mass of our person, which is 70 kilograms. And the distance between the two, which we've conveniently already converted to meters, so 3.78 times 10 to the 8th meters, and that's squared. So we compute that, and we should find that the force is 2.4 times 10 to the minus 3 newtons. In part B, then, we're asked to compare this to the gravitational force that the Earth exerts on the person. So we could do this in the exact same way with this gravitational equation. So we'd plug in the mass of the Earth instead and the distance between the center of the Earth and the person. But we've been doing gravitational forces from Earth for a long time in kinematics, and so we also just know from that the gravitational force that the Earth exerts on a person, at least on the surface of the Earth, is going to just be the mass of the person times g, 9.8 meters per second squared. So we'll just do that because it's a little simpler here, but both methods would give us the exact same result. So we plug in our values, so 70 kilograms again for the person, and 9.8 meters per second squared for gravitational acceleration, and we should get that that is 690 newtons. So that's the force from Earth, and we're asked to directly compare this with the force of the moon, so maybe we'll take the ratio. So the force that the moon exerts on the person divided by the force that the Earth exerts on the person, so that's just Fg that we just found. So we have 2.4 times 10 to the minus 3 newtons, and then 690 newtons. And so when we evaluate that, we find 3.5 times 10 to the minus 6. So that tells us that the moon is the force of the moon is about 1,000,000 times weaker than the force from the Earth.